question 2. We have an electron moving parallel to the x-axis. Okay, so an electron's negative. Here's the x-axis. Okay. It has an initial speed, so initial speed VO, equal to 3.7 times 10 to the 6th meters per second. Its speed is then reduced to 1.4 times 10 to the 5th at a point 2 centimeters away. Okay, so 2 centimeters, 0.02 meters from here to here. And at this point, that electron has a final velocity 1.4 times 10 to the 5th. Okay, so it slowed down. Calculate the electric potential difference between the origin and this point. Okay, so there'll be a potential difference. Remember, potential difference is just the change in V. And from our last problem, we had, it was electric field dotted with a distance. Okay, but in this case, it doesn't tell us electric field. It does give us a distance, but we can't go off of that because we need to know the electric field. Okay, so we need the other equation for delta V, which is just the change in energy, our potential energy, over the charge. Charge we have said it was an electron, so we know what the charge is of an electron. We know this to be negative 1.6 times 10 to the negative 19 coulombs of charge. Tricky part on this one is figuring out what the change in potential is. Okay, change in potential had to come from somewhere. Well, it had a bigger velocity here than it had here, so it lost some kinetic. Whatever it lost in kinetic will get added to its potential because energy cannot be destroyed. So let's find out what the loss of kinetic is. Okay, so I'm going to do the change in kinetic energy, which is just 1/2 mv final squared minus 1/2 mv initial squared. Okay. We're going to have 1/2 the mass of an electron. Mass of an electron, 9.1 times 10 to the negative 31st kilograms. Okay. And then we're going to multiply that by Vf squared minus Vo squared. Okay. Vf squared is going to be 1.5 times 10 to the negative 5th. Vo squared is going to be 3.7 times 10 to the positive 6th. Okay. Positive 5th, positive 6th. If we plug those in, we do that out, we should get that the kinetic energy is a negative because it lost kinetic energy of 6.23 times 10 to the negative 18. If this is how much kinetic energy was lost, that means that we gained it at this potential and this potential energy, which means our delta V is equal to the change in potential it would have gained, 6.23 times 10 to the negative 18 joules of energy. And we're going to divide that by the charge, negative 1.6 times 10 to the negative 19 coulombs. Okay, joules per coulomb. Calculate this out, and we end up with negative 38.9, or as your answer goes, negative 39 volts. So that is the potential difference between those 2 points based on the velocity. You have to use a conservation of energy. Part B to this says at which point is there a higher potential. Okay, this is a negative charge. Negative charge is going to want to go to a higher potential. It's negative likes positive, so it will go to a higher potential, which means the fact that it is slowing down as it goes here, it is being pulled back towards the higher potential, which means the origin must be at a higher potential.